Today, we such mathematicians have gathered here for a great lecture on life of pi, organized by the Department of Mathematics at St. Philomena's Autonomous College, Mysore. I, Premier Pinto, 2nd BSc, welcome each and everyone for the online webinar. Our universe is controlled and blessed by the heavenly bliss. With these blessings, all our work will be indeed a great success. So let's begin our webinar with a prayer service. Over to Evelyn and group.
Light of the world, you step down into darkness. Open my eyes, let me see beauty that made this heart adore you. Hope of a life spent with you. Here I am to worship, here I am to bow down. Here I am to say that you're my God. You're altogether lovely, altogether worthy, altogether wonderful to me. King of all days, so highly exalted, glorious in heaven above. Humbly you came to the earth you created, all for our sakes became poor. Here I am to worship, here I am to bow down, here I am to say that you're my God. You're altogether lovely, altogether worthy, altogether wonderful to me.
Thank you, Evelyn and team, for invoking God's blessing amongst us. Being an Indian, it's our culture and tradition to welcome the gathering. So I call upon Nachiket to deliver the welcome speech.
Good morning, everyone. Before I start, let me just clear up that because we have a lot of people joining here online via YouTube and everything. This is a webinar organized by the mathematics department and not the movie Life of Pi. So let me just clear it up. You can find that link in the description to this video. No, I'm just kidding. Okay, let me start. Beauty has two forms. One which is obvious to the human eye, sort of symmetries and a beautiful face, for example. But the other form which is not so obvious to the human eye. It requires a keen mind to understand this beauty, a lot of patience and a lot of hard work. Mathematics is a very good example of such beauty. Two reasons why math is beautiful. For example, it represents some sort of fundamental truth about this universe. For example, if you take the fact that the circumference of a circle divided by its diameter gives a constant no matter how big a circle you can draw. It's fascinating. We did not invent this fact, but it's true. We just discovered this thing. And the other thing is that you can write a set of equations on a piece of paper, which are nothing but merely scribblings, which have the power to describe this universe in all its detail. For example, we can describe this universe using quantum electrodynamics, which describes the motion of electrons to a very high precision, and also the biggest things in the universe, such as black holes and wormholes, which are described by general relativity. Incidentally, today is also the birthday of Albert Einstein. So mathematics is in certain way fundamentally embedded into this universe. It is the language in which nature speaks with us. And it's only through such discussions can this language, which is so strange to us, can be understood by us, and we can comprehend the beauty of this language. So we have amongst us today Mr. Tejas N S, research professor and research scholar and assistant professor at the NIE College of Technology, Mysuru. I would like to welcome him to the program. Welcome, sir. We also have Director Dr. Bernard Prakash Barnes. I would also like to welcome him to the program. Welcome, sir. I would also like to welcome Father Maria Xavier, Vice Rector in his absence, and also Father John Paul, Campus Administrator. I would also like to welcome sir. I would also like to welcome the principal, Dr. Alphonsus de Souza. Welcome, sir. We have amongst us Vice Principal and HOD of Mathematics, Sanjay Nayak. I would also like to welcome sir. We also have Mr. Ronald Prakash Kutinasu, IQAC Coordinator. I would also like to welcome him. Welcome, sir. We also have our academic advisor, Nagaraj sir. I would also like to welcome him. Welcome, sir. We also have staff and students joining us online and offline here physically. I would also like to welcome all of them and thank you.
Thank you, Nachiket. Now I request Reverend Father Dr. Bernard Prakash Barnes to address the gathering.
Good morning to you all. As we all know, today we are celebrating International Mathematics Day. Hence, I wish all the participants International Mathematics Day. I would like to start with a quote. Life is a math equation. In order to gain the most, you have to know how to convert negatives into positives. Pi Day is an annual celebration of the mathematical constant pi for the first 3 digits, 3.14, match with the date March 14th. Founded in 1988 at the Exploratorium, Pi Day has become an international holiday, celebrated live and online all around the world. It is also coincidental that the physicist and mathematician Albert Einstein was born on the Pi Day. Pi Day has been observed in many ways, including eating pie, throwing pies, and discussing the significance of the number pi due to a fun based on the words pi and pi being homophonous in English, and the coincidental circle shape of many pies. On this day, the Department of Mathematics of our college is organizing a guest talk on significance of pi, that is life of pi. Hence, I congratulate the Department of Mathematics for organizing one-day webinar. Congratulations to the Maths Department. I would like to conclude stating that simplification is not only valid in mathematics, it teaches to simplify the complexities of life. Learn maths in the best way and make a best use of this webinar. Thank you and wish you all the best.
Thank you, Reverend Father, for your treasured advice. Now I call upon Uttam to introduce our chief guest, Mr. Tejas N S, to all of us.
A very good morning to one and all present here in this webinar. Now, I would like to take the privilege to introduce Mr. N S Tejas, our resource person for this webinar on Life of Pi, organized by Department of Mathematics, St. Philomena College. Mr. Tejas completed his Master of Science from University of Mysore and Bachelor of Education from Bangalore University. Besides having this degree, Sir also had acquired postgraduate diploma in Master of Computer Application from Center of Advanced Computing. He is a member of Board of Examiner UZ, University of Mysore. Currently, he is serving as an assistant professor in mathematics in National Institute of Education College of Technology, Mysuru. He was a resource person for the workshop in WX Maxima in the University of Mysore. A warm welcome to you, sir, for today's webinar. I am handing over today's series over to you, sir.
So, good morning, everyone. It's my privilege here to be in this college to just present a talk on life of pi. So, basically, my favorite number is pi. So, when usually someone address me or ask me, what is your favorite number? I usually tell the number pi. I don't know why I fell in love with this number pi from my high school days. So, basically, we learned from the elementary schools that pi was approximated value as 22/7. Later on, when I went to post graduation, I came to know the truth that it's not the exact value of pi. So then I just went behind in searching of how the digits of pi goes on. So let me try to present you today about how this life of pi goes. So in today's talk, I'll be focusing on 5 things. So the first, we will try to see the origin of pi. So basically, pi was not invented, it was actually discovered. So next we will see the evolution of pi. And we will see the applications of pi, which is very huge. In fact, it is used in many fields, not only in mathematics, it's almost every fields we use pi. And we will just see some facts about pi. Maybe you might have heard of. So I'm just trying to share the facts that I know. And at the final, so we will just conclude the session with small quiz. Okay, so basically here we are not giving any grade, so it's just fun to know about some facts about pi. So we will try to play a small quiz. So to begin with, first we will start with the origin of pi. So actually pi is actually an Egyptian mythology. So basically when they started calculating the relationship between the height of the pyramids and the vertical heights, that is the ratio finding the vertical height of the pyramid and the perimeter of the base, they started the concept of pi. And they also believed that, that is Egypt civilizations believed that the pyramids were built by the principles of pi unknowingly. So before 1700s back, people just referred this pi as a quantity which is 2 times the diameter, that is, which gives the circumference. So basically we know C is equal to 2 pi r. So the formula that we have learned from the elementary schools. So, but that symbol pi was not symbolized. So the mathematician William Johns in the year 1706 first recorded the use of pi. So basically he recorded the use of pi. And this symbol was made popular by the mathematician Euler. So though William Johns symbolized it, but yet Euler mathematician was the one who made this symbol popularized today. So actually it's a Greek letter. Maybe we know that Greek has capital letters and small letters. So the 16th letter, that is the lowercase 16th letter, is this word pi. Actually it is derived from the Greek letter, so which actually means that perimeter. So basically I have used the screenshot. I have taken the screenshot of Google Translator. If you translate the perimeter to Greek, it tells that it is pi perimeters. So basically the first letter there you can see is pi. So that is why the William Johns named this Greek letter pi. So this was how the symbol came. So as far the definition is concerned, we basically know that the pi is the ratio between the circumference over the diameter. So that can be regarded as a rational number, but in fact, it's not a rational number because the ratio that we are calculating, that is the circumference upon the diameter, though it is 3.14 constant, but still today we don't have the exact significant digit after decimals. So basically it's an irrational number. So here is just a visualization how we can open a circle and we can make the circle to sleep on a number line so that that number represents 3.14 on the number line. So this is, as I said, this is the definition that we have learned from the elementary schools, that if you divide the circumference upon the diameter, we get this result. So basically this is an elementary thing that we know from elementary schools also, but many mathematicians work with this number pi. So let us try to see the evolution of pi. So for everything there is a beginning, according to me. Of course, for anything that need to be started, there should be some beginning. So now let us try to see how pi was discovered and evolved through the time. The first time people hunt for pi was Egyptians around 5,000 years ago. So here we can just see 4 generations, like 4 eras that we can see, where many mathematicians and physicists and some unknown people who contributed for finding the approximations of pi. So it is the first time in the 17th century, Archimedes and their friends started using geometrical tools to discover the pi. So basically here they use geometrical ideas like how you can circumscribe a circle with polygons. So basically here polygons plays an important role. So Archimedes used that kind of an idea. So I'll just illustrate that in some time. Next was Newton era, where they used calculus. So basically like integration, differentiation, to find the approximation value of pi. And Newton and his friends, many mathematicians, Leibniz, worked towards finding the approximation value of pi. Next, this is a great invention in the 20th century, which was described as a Ramanuja era. So where Sir Srinivasa Ramanujan discovered the value of approximations without any kind of formal education. So basically we know about Srinivasa Ramanujan sir. And now in the 21st century, that is modern era, we are using computer systems to find significant digits of pi. So just I'll be sharing you what is the digit that we know till today. So let us go one by one. So first, approximation of pi using geometry. So this was basically started by Archimedes. So you can just see in ancient times, this was the unique method that they used to calculate pi. So here what they do is they add more number of sides to the polygon so that its area, that is the area of the polygon, approaches the area of the circle. So that is how Archimedes started. And many other mathematicians use this polygon method to compute the number pi. Chinese and other mathematicians in the surroundings used 300 sides of polygons to get the precise value of pi. And some unknown mathematician used 25,000 sides to calculate the value of pi. So his name is not recorded in anywhere, but yet that discovery was recorded. After this approximation of pi using geometry. Next, John Wallis in the year 1655 holds an important place in taking about the pi using a problem. So he was basically solving a problem on area of a quarter of a circle. So in fact, he was the first mathematician to discover pi has an infinite product of rational numbers. So today, these two problems are well known to us. We can derive the value of pi using the infinite product of rational numbers using a reduction formula. So basically, this is nothing but a reduction formula that we are using today. And unfortunately, Wally didn't know that this will yield to a reduction formula, that is integral 0 to pi by 2 sine to the power of m dx. So using that relation, we can derive the approximation of pi. But the convergence was very slow here. But however, this gave the gateway, and this was the first analysis of pi in this true sense. Next comes a Brownker. In the year 1660, he just modified this Wallis formula as a continued fraction. So now he modified the formula that was given by Wally to a continued fraction. So this is how he represented pi using continued fractions. So I'm not going in depth to it of what is exactly a continued fraction and all. So this was again an invention, and he was influenced by John Wallis' work. But again, unfortunately, here the convergence were very slow, and this continued fraction was not used for practical calculations part. So still there was a need for many mathematicians to go beyond this. So next comes James Gregory and Leibniz. They used the series of expansion of tan inverse function. So we can express tan inverse function as an infinite sum. So basically we can use a Maclaurin series or Taylor series to represent any continuous function. A differentiable function has an infinite sums. So these two mathematicians used tan inverse x expansion series to get the approximation value of pi with suitable substitution. So we know that tan inverse 1 is pi by 4. So with the suitable substitution, that is x is equal to 1 in that expansion, they got the approximate value of pi. But the convergence again here was too slow, and it took 300 terms to obtain 2 decimal digit after pi. So if you just try to expand 1 minus 3 upon 1 minus 1 by 3 plus 1 upon 5 minus 1 by 7, you need 300 terms to get the 2-place precision value of pi. So the invention of this tan inverse x function was unfortunately again didn't help the calculations for basically practical calculations. It didn't work. So next, Newton took the initiative to find the series expansion using sine inverse function on the same idea, basically how those two people, Leibniz and worked using tan inverse x function. So here they used a sine inverse x function to express it as an infinite series, again with some suitable substitution of x, that is 1 by 2, because we know the fact that the sine inverse 1 by 2 is pi upon 6. So that led to the infinite series pi is equal to 6 times. So this expansion needed only 22 terms to get 16 decimal places. So the conclusion that we can arrive at here is this sine inverse function converges much faster than tan inverse x function. So this was very close to the expansion of pi up to 16 decimal places. So this was actually a great inventory by Newton. Of course, next, Euler came into the picture in the year 1748 when he was trying to solve a Bessel problem. That is the summation of the reciprocals of the squares of the natural number. He arrived at approximating the value of this summation to pi square upon 6. So, and he was the first one who started squaring an irrational number. So pi square upon 6 was the first time where Euler discovered while he was solving another problem. But however, the precision again here was not so good like Newton, how we used the sine inverse x function. So here, the next era, that is Srinivas Ramanujan's era, was in fact a great discovery here because he found several infinite series. So many mathematicians just found one or two, but Srinivasa Ramanujan found several infinite series of pi. And here, one of the famous one is this 1 by pi is equal to 2 root 2 upon 9801 summation. So you have basically, I'm not going into the derivation part of it, and moreover, even I need to study about this. But however, this famous infinite series led to many discoveries. And today, in fact, computers use this algorithm. I'll just tell you that about in some time. And the beauty of this infinite series is that just only one term will give the 6 decimal places of pi. Whereas Newton or Leibniz used 300 terms, 20 terms to get precise decimals. But this infinite series, with only one term, we can get 6 decimal places approximation of pi. And just by taking 2 terms of the series, we can get 14 decimal places. 14 decimal places. So this was the great invention by Srinivas Ramanujan sir. And he is actually a living mathematician, Hayashi. In the year 1989, he found another infinite expression for pi in terms of Fibonacci numbers. So basically, we know Fibonacci numbers. So he connected Fibonacci numbers with this pi, with again an infinite series. So one thing that I usually admire here is that this number pi can be expressed as a sum of infinite terms. So this again led to a great invention in mathematics, that even an adding infinite number of terms leads to a finite answer. So logically speaking, it's quite not much accepted fact that how if we add infinite terms, we get a finite answer. But this invention of pi, that is finding the approximations of pi, made us to think a beautiful mathematical logic that even adding infinite number of terms of the series, we will be able to getting a finite answer. So the next present era is calculating the approximation of pi using computers. So here we are, in fact, in Maxima, we have a program to find the pi digit up to 50 decimal places. So even we are doing it in our daily life, where we use softwares like Scilab or Maxima to compute pi up to 50 decimal places. But however, the scientists and the computer scientists and mathematicians were not satisfied with this 50 decimal places. So they went on to trillion places, that is 10 to the power of 12, 1 followed by 12 zeros. So they have discovered recently in last year, August, a team of scientists from Switzerland, they have claimed that they have used a supercomputer to calculate the value of pi up to 62 trillion digits. 62 trillion. So we need to imagine that it has a digit after point 10 to the power of 12. So it's really a hard pain-tasking thing to type and display it here. So it took approximately for them 2000 odd pages to write those numbers. Well, the previous, the Google and engineer holds the record for calculating pi up to 50 trillion digits. But the best part here is, though we are using computers to calculate the approximation value of pi, it uses an algorithm called Chudnovsky algorithm, which is nothing but the approximation which was given by Srinivasa Ramanujan. So this algorithm is basically designed by and the motivation for designing this algorithm was Srinivasa Ramanujan, sir. So the present computers, what we are using to estimate the value of pi, uses most of the fact and the proofs that was developed by Srinivasa Ramanujan. And the question is why this approximation is needed. So basically now we just talk about approximation, that is getting 16 decimal precision, 20 decimal precision, 2 decimal precision. And of course, when it comes to the computer stage, we are talking about a trillion places precision. So the thing is it needed? So here I just want to present one example of just 2 decimal places. So just think about this. 1 raised to the power of 365 just gives you 1. But just add 1% more to it. That is just 0.01 to 1. And if you add just 0.01 to 1, and if you raise to the power of 365, it is giving a big result. So the comparison of 1 and 37.8 is so big. But however, comparing 1 and 1.01 is so small. Suppose if we go on the contrary, that if you make 0.01 less to 1, of course, which is very close to 1, but still the result is 0.03. Again, it is there is a huge difference between 1 and 0.03. So just 1% more will take you a far distance, and just 1% less will go back. We will go back to less than 1. So these kinds of approximations are needed for us to get the precise calculations. So for instance, if we take to calculate the Earth's circumference, or to find the trajectory of spacecrafts, so basically they use these kinds of approximations, so decimals they use. So just rounding off this number pi to 9 digits after the decimal, we can calculate the Earth's circumference precisely, accurately. So approximation is needed here. So basically we talk about calculating Earth's circumference or total surface area. It looks like a sphere. So if you want to get the desired result, accurate result, it is needed for us to use the decimals to more significant digits after 9. And even many spacecrafts, they use this pi. They use up to 15 digits after the decimal of pi to get the accurate calculations. So next we will just think about the applications of pi. So where pi is used. So of course we are using pi everywhere. So basically it is used in geometry. So Euclid's geometry, what we are learning with here, I'm just giving example. So just to find the area of an ellipse, we need pi. It's not only area of the circle. because when we encounter the word pi, we usually think about the circle, but it can be even extended to ellipse and many other things like cylinder, cone, where circle is involved. So it's not only the circle takes the credit of using pi. So basically other geometrical figures uses the concept of pi for many calculations. And also we've seen a regular convex polygon. So basically it's a closed figure where this pi can be connected to find the sum of the internal angles. So we have studied some angle sum properties of a triangle, angle sum property of a quadrilateral or anything. So this can be generalized by the concept of pi. So suppose in this formula S is equal to n minus 2 times pi, if you put n is equal to 3, so you'll get pi, which is nothing but an angle sum property of a triangle, which we have learnt in the elementary schools. And if you put n is equal to 4, you will get 2 pi, that is 360 degree, that is angle sum property of a quadrilateral. So even it is used in regular polygons. And it, as I said, it can be used to represent an infinite series. There are many infinite series that we saw now, Leibniz, Newton, Srinivasa Ramanujan, many mathematicians and physicists, in fact, used the concept of infinite series to represent pi. And this is one of the famous series by name Madhava series or a Leibniz series, which again gives the approximation value of pi. And also it is used in physics. Most of the formulas in physics uses the concept of pi. So if you take the Kepler's law of planetary motion, or if you want to calculate the period of a simple pendulum or uncertainty principle, it uses the value of pi to get the desired results. And of course, in mathematics, in integrals, we find we have done a bunch of problems where we have used pi as some limits or any other complex analysis using Cauchy's integral formula or Cauchy's integral theorem or Riemann zeta functions. We use this concept of pi again. And this is one of the beautiful equation. Actually, this has been rated as one of the beautiful equation, e to the power of I pi plus 1 is equal to 0. The beauty lies just because e to the power of I pi plus 1 contains different types of number. So just if you see 1, it is a natural number. Of course, it is a whole number, integer, rational number, a real number in fact. But still 1 can be taken as a natural number, 0 is a whole number, a rational number, e, I, pi, where you have an irrational number and also a complex number. So this one equation alone gives you the complete number system idea. Starting from natural number to complex number, you can see in this equation alone, e to the power of I pi plus 1 is equal to 0. And again, here we use pi. And some of the functions like gamma functions, beta functions, again, it uses the concept of pi, improper integrals to evaluate. So this number pi is a basic integral to understand geometry, because most of the geometrical shapes are made up of circles. Of course, there are some geometrical shapes like square and rectangle, which is nothing to do with circle. But however, most of the geometrical shapes, to understand the nature of it, to understand the characteristics, we use the number pi. And pi, of course, has been used widely, not only in mathematics, it is also used in physics, astronomy, architecture, etc. And today, this pi is also used in creating some musics also that I'll share in some time. So it is one of the fun fact that I saw when I went behind this pi. So now let us try to see some fun facts about pi, which I personally admire of. Hopefully even many of you here might know. So as I said, you can just memorize the 100 digits of pi using a pi song. There is a song on pi. So if you just try to understand the lyrics of that pi, you can memorize. You can just Google it. It is available online. Okay, it is an official song, okay, by Science page in YouTube. If you just memorize the lyrics and count the number of letters in each word, that represents the 100 digits of pi. And one Indian student achieved to memorize and tell the pi value up to 70,000 decimal places. And it took for him 10 hours to tell. And this was a Guinness World Record in the year 2015. So till now, no one has break this challenge. So we are open to this. So if we can memorize and tell the digits, because today we know trillion digits. So he has just memorized 70,000, just 70,000. So today we have 62 trillion digits. So if we can memorize and if we go up to 70,001, we can be in the Guinness World Records. And the next is, I usually use Instagram. Of course, most of you are here. And there is a unique page called Pi Digits Daily. Okay, so there a group of admin there just post a digit of pi daily. So today they will be posting the 670th post. That is the 670th decimal digit. So today they will post. Usually they post in the evening time. And the best part, what I loved in this Instagram page is the description of the page. So the last line you can just see they have posted that planning to post until the last day of Instagram. So the admins knows that pi is irrational and it is never ending. So there are a group of people, and of course even you can contribute to this page. So if you can represent any image which represents that numbers, you can just see there. I have just embedded some screenshots where a ring which represents 0 or earth is 1. So they are just trying to connect images and numbers, and they are posting it daily. So of course there are 2,814 followers. Among them one is me. And this is not an advertisement for this page for you people to follow it. It's just what I usually admire of. Usually I just follow daily. And this is one of the interesting things that I discussed with my colleague in the college last week when we were having just a cup of tea. So usually pi is just a number that is 3.141592, which is quite irrational. And here I have just represented only up to 15 digits, not even 15. In elementary schools, we thought that the pi approximate value was 22/7. So if you just see the approximation value of 22/7, we will get only 5 digits after decimals. Only 5 digits. So after that, it will start recurring. So basically 14286. Next, again, you will get 14286. But there is one more a best approximation. 355 upon 113 will give more digits. So if we can change the textbook that what we have learned in the elementary schools, maybe we can take this approximation. Instead of learning 22/7, we can replace it by 355 upon 113 to get the precise value of the areas or whatever. So you can just do it later. So I did this problem. So after 3 significant digits, the volume or the area which is related to circle was changed, in fact. So just one small fraction change the complete area or volume. Complete in the sense I'm just telling about after 2 significant or 3 significant digits. But however, we are not much interested because we usually round it off to 2 digits. But still, 355 upon 113 is the best approximation that we can take if we can equate this number pi to a rational number. So there are some mathematical jokes which is related to pi. Suppose if I ask you what's the opinion on this pi. So if you remove that pi in opinion, it just becomes an onion. So in the word opinion, if you just remove pi, so it's just, and there are plenty of cartoons available today where they make fun of this number pi. So the last part, we will have some quiz. So just test your knowledge about pi, that what we know. So again, as I said, this is not a grading thing. So you can easily guess, and no negative marks, nothing, no marks is nothing is there. So simply kind of a guess that we can play with. Yeah, so the first question here goes, who was the first person to calculate pi? Yeah, I'm getting some response from the audience here physically. Yeah, of course, it's the William Johns. So before that, no one started. They just stated. No one started actually. They just stated. So he was the first one to go with calculation of pi. So that fire of finding the approximation digits was started by him. Yeah, so it's Johns, correct? Yeah, everyone said, see, that is why I went with that answer, but the answer is not that, it's Archimedes. So he was the first one who started the concept of polygons. So that was the first slide that I showed you. Yeah, William Johns symboled it as pi, but the one who started calculating pi was Archimedes through geometry. So that is the first era. So he just stated, but William Johns, he symbolized it. But the first one was Archimedes. So he basically started that. So maybe I presented the value of the pi up to 10 digits. So if you could have noticed that, you can answer this question. What is the 7th digit of pi? Or if you want to know, even you can memorize the lyrics, as I said. Up to 100 digits you can memorize. So any guess, what is the 7th digit of pi? So 3.14 is easy to guess. Yeah, it's 2. 3.141592. Of course, this approximation was given by the new fraction that I told today, 355 upon 113. So if you would have observed that also, you could have answered this question. Okay. Well, pi is a letter in which alphabet? Greek. Obviously, this is an elementary thing. So 16th letter of lowercase is pi. So Greek. Yeah. When was the first Pi Day celebrated? Actually, I was about to tell this, but in the introduction, Father itself said that. So I just thought of skipping that. So maybe 1980. Yeah, 19 is okay, but the next 2 digits is important now. So yeah, it was in 1988, but it was started from physicists actually. Not a mathematician started celebration of pi, because usually mathematicians are kind-hearted. They give everything to different fields. So even physicists started celebrating, and there are few institutes around the world, they give a holiday to celebrate this Pi Day. And in fact, in this college, you are celebrating Pi Day. Really, personally, I felt happy. Okay, let us have some pi later. Okay. Yeah, again, this is quite an easy question. Who was born on Pi Day? Of course, there are many, maybe there are many people who was born on this Pi Day, but out of these 4 options, so the physicist was born on this day, Albert Einstein was born. Yeah, and again, I'm going to an elementary thing. So which of the following statement is correct about pi? See, when we try to see the advanced nature of pi, we try to forget about the elementary part of pi. So basically, we talk about decimals. But decimals, what kind of decimals? Is it a terminating, non-terminating, recurring? It's non-terminating repeating. So suppose if you go with an option, non-terminating repeating, what happens is it becomes a rational number. So the argument of pi being an irrational becomes a contradiction to that. So it's a non-repeating and non-terminating. So basically, you can't guess the next digit easily, like in recurring cases. See, 22 upon 7, you can guess the 7th digit. 8th digit you can guess if you know the first 6 digits. So you just divide 1 upon 7, you will get the 6 digits. So later it will start recurring. But this pi will not recur. So it's basically a non-repeating and non-terminating decimal. Yeah, again, what is the value of pi? Up to 5 decimal places, if you can answer it. Yeah, again, 3.14 is okay. So the elimination, even 3.141 is okay. So the elimination starts for the last 2 digits. Option A, 3.14. Yeah, I'm getting some answers through chat box. C, D, you're guessing. Okay, fine. Yeah, again, it's 3.141592. So at least today you memorize up to 6 digits. 3.141592 is the first 6 precise decimal places of this number pi. So at the last, I want to conclude that pi never dies. So the reason is it has no end digit. It is immortal. Of course, it has no date of birth like us, but still it has no death date also. Maybe that is the why this pi is so kind of fun to learn for many mathematicians, and there are many math lovers who go behind this number pi. And from my side, I wish you all a happy International Pi Day. And I thank the organizing team here for organizing this event, and just to share my knowledge in front of you people, because each year I usually celebrate this Pi Day, and I can remember this college and time spent with you all. Thank you one and all. Thank you.
Thank you, sir, for meaningful thoughts, and thank you, Uttam, for introduction of chief guest. If any questions, you can put it in the chat box. Living in a state of gratitude is a great way to grace.
Maybe I have not explained well about pi.
If there is any questions, put it in the chat box. Living in a state of gratitude is the great way to grace. Now I call upon Evelyn to deliver the vote of thanks.
Can I talk? Yeah, there is one question. Who first thought to measure pi and why? So that was one of the question in MCQs. Archimedes was the one who started to measure pi. And the main motto was to, see, in the olden days, the geometry started just to measure the area of the circle or the circumference of the circle. So to answer this question, Archimedes started measuring pi. So he was the one who started.
while making the wheels for the automobiles. So is there any significant role for the digits?
Yeah, of course, that is what I said. As I said, one example, if you are designing any spacecrafts, so they need 15 digits precision for the pi value to get the desired results. So even when it comes to chemistry, hydrogen molecules, they need these approximations where the pi is involved, because the structure of the atoms are basically a kind of a sphere. So there is a need of all these approximations.
Thank you, sir.
And there is one more question. So we have been taught that rounding of the figure while solving the problem. Rounding, I'm not getting maybe it's the rounding of the digits, I guess. So basically in elementary schools or whatever the problems that we daily do, we usually round off to 3 or 4 significant digits, that's all. So we are okay with that, but not all are okay with that. So they want some more approximations. So this inventory may lead to a big discovery in next 100 years. So it's just a question mark, because John Wiley, when he was solving the area problem of the circle, he never knew that that will be a new kind of an integration that will rise. So that is reduction formula. He didn't knew that. So he just stated the problem, but later on other mathematicians researched about that problem and they discovered a new technique of integration. So maybe that is why these approximations of pi are of interest for many things.
Since we are talking about applications of mathematics and stuff like that, we can use mathematics to describe a lot of things. As I quoted in my welcome speech, like we could write an equation in physics and we could launch satellites into space using this mathematics. And there are also abstract areas of mathematics where there are no practical applications, like maybe the Mandelbrot set or something like that. So what are your ideas on why is mathematics that way? Like, why is it such that we can write an equation maybe, or it represents something about this word? Why is it so something that we can't really understand but yet works? Why is it that way?
Yeah, actually, even I was confused about this kind of a part. So we do something, but at the end of the day, what is the use? Suppose you calculate some area of a circle or a cylinder or whatever it is basically. So what is the use of that? Maybe I may not use that, but there are some people, they need to use that. So mathematics was developed in such a way that they didn't have the motto, yeah, for this purpose, we need to invent this. No, that was not the idea. Of course, there are some things like Newton wanted to understand the rate of convergence, rate of change of body. So he discovered calculus. So we usually tell that he invented calculus. But there are some other notable mathematicians before Newton who stated these kinds of things in the other words. But their motto was not to put their idea in any other fields. So they just discovered, and they didn't knew that this will be helpful in the future days. So maybe the invention of today might not help today, but it may help in the future. So that kind of many inventions is done in mathematics. Not only in mathematics, of course, there are many other even physics applications also where we can see. Suppose you just take a present situation of batteries. So battery, when they start invented, they somewhat used in torches or like that. But today that invention of battery is gone to the electric vehicles. So the motto for designing a battery was not only to work with the torch. So that idea gave a big gateway to solve many problems in the environment.
Following upon that, there are practical applications too, but we also do it for just its abstract nature. Like there are certain theorems which are just done for the beauty of the theorems. Like, for example, Euler's formula or something like. Does mathematics represent something fundamental? Like, it's able to describe this word so beautifully, like with these mere scribblings of things on a piece of paper, we can calculate things that are thousands of miles away in the space, like black holes and everything.
Exactly.
So does it represent something about this nature, like your ideas on it? Like I don't think we have a solid answer on that, but
Yeah, exactly.
do you have
It's just,
any
it will be a
ideas?
kind of a formal discussion, because as I said, we cannot have the motto. So maybe some mathematicians like Riemann, they did mathematics just to satisfy their soul. The purpose for them was not to impress the society. And even we have a Poincare who solved a problem, Poincare conjecture we have. So those mathematicians work for the betterment of themselves, to satisfy their soul, not to impress others. So there are kinds of things that this will work. So maybe it may not work for me today, but someone may take that credit, or in the future, we don't know.
Thank you, sir.
Yes, sir. Yeah. No, actually, that was. No, actually, yes. Even I had that. He used just 3, but it was not more significant. And the theory was actually dissolved, because now today we have many precision, exact values about that. So even that theory failed, in fact. Yeah, it's a kind of a failure, but that led to an invention to discover what exactly the truth. So that is, it's not a complete failure. In fact, it is an eye opener for others to think why it's wrong. Yeah, kind of evolution.
Sir, there is a question. Can't we use the pi value till it gets a complete value?
No. So yeah, okay. No, actually, because pi is irrational. As I said, pi never dies. So suppose if we find the last digit of pi, pi will die on that particular day. So since pi is immortal, we cannot find the last digit, and there is no end to it.
Doesn't pi bring out the aesthetic nature of mathematics? What do you say, sir?
Yeah, of course. See here, that is what, see, suppose we see pi has a number, but a musician saw pi in a different way. So it's just a kind of a perspective nature, how you are seeing pi. And when I just even said about the fact that Rajiv, who memorized the 70 decimal places of pi, and he did a Guinness World Record, he's nothing to do with any type of mathematics. So his aim was just to memorize 70,000 decimal places, and he just said. So that is how the way he has taken the pi into his life. So it's just a kind of a perspective, that's all. So it's not exactly you need to use the pi in this context. So if that was the case, Newton, Leibniz were not viewing the problem of pi in a different angles.
Sir, another question. Then why don't we use pi? Then why don't we live pi and find some finite value?
Yeah, again, it's kind of a, I'm getting a spiral of the same kind of a questions. We can't use pi as a finite value. We can't use pi as a finite value. So the thing is, suppose if we try to start calculating the last digit of pi, maybe our life will end, but pi will not end. You need to give the power of attorney to some other people to continue your work, and you need to stop doing it.
Over to Evelyn for the vote of thanks.
Firstly, I would like to thank God by giving glory to the Almighty God for making this occasion a resounding success. It gives me an immense pleasure to deliver the vote of thanks for this event to all the dignitaries assembled here. I would like to thank our chief guest, Mr. Tejas, research scholar, assistant professor of NIE College of Technology, Mysore, who honored this function with his inspirational thoughts. I request Sanjay sir to give a token of success for the chief guest. I give thanks to Reverend Dr. Bernard Prakash Barnes, Rector Manager, Reverend Father Maria Xavier, Vice Rector, Reverend Father John Paul, Campus Administrator, Dr. Alfonso de Souza, Principal, Mr. Vidyadhara, Sanjay Nair, Vice Principal and HOD of Mathematics, our beloved teacher, Mrs. Shruti Menas, Dr. Ranal Prakash Kutina, IQAC Coordinator, Dr. Sunil D'Souza, IETC Coordinator, Mr. John and Swaminathan, Technical Support, Nagraj Sir and Thomas Sir, Department of Physics, and all the faculties. Last but not least, I would like to thank our fellow students and friends of our college, as well as the students attending in YouTube. Thank you.
Yeah. So if there is no last question, maybe this questionnaire is also immortal. So it has.
No, sir, there is. So can I speak?
Yeah. Yeah.
So the thing what I wanted to ask was, you said pi value has been used in many fields like astrophysics and many other things. So don't you think when you are defining something to, as you said, 1 to the very small number will make a large difference? So if you don't have the last digit itself, how will you use it? So it is better to leave it now.
Yeah. So again, see, so in the Newton's era or Archimedes era, we just we knew only 2 significant digits of pi, but the calculations was precise. But see here, there is something like there is no wrong or right. It is something to get the accurate or desired result that we are trying to get the value of precise. So suppose if you want to find the area of circle, basically I'm talking about the area of pi. So you cannot find the exact area of circle. Of course, what we can do, what you can do is that you can find the precise area of the circle of that particular radius. So you cannot find exactly the value, I mean the area of the circle for that given radius. So to get the precise answer, we need these kinds of approximations.
So it is of no use now, sir.
Thank you, sir. I thank each and everyone for being the part of this webinar, and I hope you have gained a great knowledge about pi. Good luck and thank you. The feedback form will be sent. After submitting it, you will get an e-certificate. It will be put in the chat box. The feedback form link will be put in the chat box. After submitting it, you will get an e-certificate.